Hello everyone, this is Reza Vaezi and I'm going to cover the basics of association rules analysis in this recording. Association rules analysis or affinity analysis is a type of data mining methodology that seeks to find frequent connections between variables in a dataset. Basically, it will answer the question of what goes with what. Association rules were originally derived from point-of-sale data that describes one transaction consisting of several products. But if you think for a second, it can apply to any other basket-like data structure. For example, banking products used by a retail customer such as saving accounts, money markets, and CDs can point us to other possible products to offer to the customer. Or unusual combinations of insurance claims can be a sign of fraud and can lead to further investigation. Also, medical patient histories can point to likely complications based on cross effects of treatment combination. Basically, it answers the question what goes with what. So, in shopping basket analysis, we are looking like cell phones will go with cell phone screen protectors, or people when they buy cell phones they typically look for chargers or the cases to put their cell phone in. The items that go together a lot are found to be associated in using this association rules analysis. One final application of association rules analysis is in tracking marketing interventions. For example, if you direct a marketing campaign to increase the cross-selling of product X and Y, then you can use association rules analysis before and after the campaign starts to evaluate the performance of your marketing interventions. If it is a successful effort, you should observe a stronger association after the intervention as opposed to before the intervention. Thus, in interpreting the results of association rules analysis, you should be careful to consider the previous marketing campaigns and product bundles because what you observe might be the direct result of an old marketing campaign instead of an organically occurring association. In order to be able to effectively interpret the results of association rules analysis or to understand analysis, you need to be familiar with few concepts. Let's start with the support percentage. Support percentage is basically the relative frequency of occurrence of a association. Basically, it refers to the number of times that the rule occurred divided by the number of observations in the dataset. Let me give you an example to understand support percentage a little bit better. Let's say that we are examining 10 shopping baskets. 4 of them contains cookie and 7 of them contains milk. Now we know that 3 of them contains both milk and cookie. Now if we are looking for the support for only milk in our analysis, it's 7 out of 10 or 70%. Remember, 7 of the baskets contained milk, so the support for milk or the relative frequency of occurrence of the milk in this data set is 70%. The support for cookies is 40%. Remember, 4 out of 10 contain cookies. Now let's look at those that contain both milk and cookie. So 3 of the baskets contain both milk and cookie together. So 3 out of 10 will be 30%. Remember, it does not matter if we say milk or cookie or milk for the support percentage. Support percentage is reciprocal, so it doesn't matter which one comes first. The support for both milk and cookie and milk are the same, 30%, because they have seen together 30% of the times. Out of the 10 times, then out of the 10 possible times that they could have been seen together or they could have been purchased together. So simply the number of times that the association occurred divided by the number of times it could have occurred will give you the support percent. And remember, the support percent is reciprocal, meaning that it does not matter we go A and B or B and A. Now let's move to the confidence percent or confidence percentage. Confidence percentage or confidence percent refers to how confident we are that when one attribute is flagged as true, the associated attribute will also be flagged as true, or how confident we are that A leads to B, or that buying A leads to buying B. Now let's go back to our shopping basket analysis example. Remember, we had 10 baskets, 7 of them contained milk, 4 of them contained cookie, 3 of them contained both milk and cookie together. So let's calculate the confidence for each of these rules. Let's calculate the confidence for buying milk leading to buying cookies, and buying cookies leading to buying milk. Let's say that we want to calculate the confidence for cookies to milk. Remember, 3 out of 10 baskets had milk and cookie together. Now, how many of them only had cookie? 4 of them. Then the confidence for cookies leading to milk will be 3 divided by 4, which is 75%. It means that we are 75% confident that people who buy cookies are going to buy milk as well. How about the confidence for milk leading to cookies? Then we still have 3 baskets that contain both milk and cookie. Alright? We know that 7 out of 10 contained milk. Now we know that 3 out of 7 contain milk and cookie together. So it's going to be 3 divided by 7, which is 43%. Now we are 43% confident that buying milk leads to buying cookie. You see here the confidence percent, unlike the support percentage, is not reciprocal, meaning that the confidence for A leading to B is different than the confidence for B leading to A. We also can call the right and left side of the confidence equation premise and conclusion, or antecedents and consequence. Now let's review these 2 measures together one more time. So support is a reciprocal measure, and it does not matter we say the support of x and y or the support of y and x. And it is calculated as the number of occurrence of an item or an item set divided by the total number of transactions. Confidence of x leading to y is basically the support of x and y together divided by the support of x. Now, can you guess what would be the formula to calculate the confidence y to x? Look at the formula for the confidence x to y. The support is reciprocal. So the support xy stays the same, but the denominator will change from support x to support y to calculate the confidence from y to x, or the confidence that y leads to x. There are other measures besides confidence and support to evaluate your rules and see how reliable or how good your rules are. One of them is called lift. Confidence tells you how good a rule is at predicting what is the consequence of an item or item set, or in other words, how good a rule is in predicting the right-hand side of a premise conclusion equation. However, the items on the conclusion side might already be very common, and that act as the main reason for observing the rule. Lift measures the power of the rule by comparing the rule to randomly guessing the conclusion side. Lift is calculated as the ratio of the confidence of the rule to the prevalence of the conclusion side. Values of the lift equal to 1 or very close to 1 indicates independence between premise and conclusion. This indicates that you can outperform the rule just by guessing the conclusion. In short, when lift is greater than 1, then the rule is better at predicting the conclusion than guessing whether the right-hand side of the rule is present because of the item frequencies in the data. When the lift is less than 1, the rule is doing worse than informed guessing. When the lift is less than 1, then negating the results produces a better rule. For example, if the rule is A and B, then C, and it has the confidence of 20%, then the rule if A and B, then not C, has a confidence of 80%. So In short, the higher the value of the lift, the better. If the value is 1 or very close to 1, it's not good. If it is less than 1, then you can negate the rule and you will have a rule with better confidence. And finally, how to find and evaluate these rules. First of all, you should consider that data has to be in transaction format before you can run any type of association rules analysis. So, what do we mean by transaction format? In this format, attributes refer to products or product categories, and rows refer to one transaction. So it will be a giant table of zeros and one, where all your products or services or all your offerings are listed as column names, and whether they exist in one transaction or not is marked by 0 or 1. 0 for non-existing, 1 for existing. So each transaction will have a record of whether one specific item or item category exists in that transaction or not, and each row refers to one transaction. So the next step, after you have your data in the desired format, the algorithm will go ahead and shortlist frequently occurring items based on the support percentage. Then you will need to generate the relevant association rules, and it will give you confidence and the lift percent. At the end, for you to evaluate if an association rule is good or not, you will look at support, confidence, and lift, and you will decide if this rule is good enough for you to act on it and suggest some insights or suggest some actionable business strategies based on your findings.